In this video, we're supposed to derive a formula for the area of an isosceles triangle. So we have show that the area A of an isosceles triangle, whose equal sides are of length S and theta is the angle between them, is given by this formula. 1/2 the side squared, or the product of the two sides, times the sine of the included angle. There's many formulas for finding the area of a triangle. The most basic one that you have is that the area of a triangle, general triangle, is 1/2 whatever the base is multiplied by the height. So if you know the base and the height, easy way, this is easy method, quick way of finding the area. And this problem, we have an isosceles triangle, again two sides, same length, and this perpendicular right here bisects angle theta. So actually, this right there is theta over 2, and this angle over here is theta over 2. Now there is a theorem that tells you that if you know the two sides of a triangle and you know the included angle, then the area is given by 1/2 the product of the two sides times the sine of the included angle. So if I use that theorem, then I have it proved. If you know the two sides of a triangle and you know the included angle, this is your formula. This will work. That doesn't have to be isosceles. It could be any triangle where you know the two sides and the included angle. But here we want to do it assuming we don't have that particular theorem. So we're going to go from scratch here. We want to come up with this formula. So this is what I'm going to do. Let's look at these two triangles right there. And notice what's given. They drop the perpendicular from this vertex here to the base. And notice here, this is a right angle right here. And that perpendicular divides angle theta into two equal angles. Theta over 2 on the other side. So I have two right triangles. Look at this one right here and this one over here. And that perpendicular divides the base. Let's call this length here the base of the triangle. So if I knew the altitude h, then I would just use this formula here. So here's what I'm going to do. I'm going to look at this angle here. Oops, I went too far. I don't want theta, I want theta over 2. So I'm looking at this triangle here, and I'm going to say that cosine of theta over 2 is the adjacent side, which in this case is h, over the hypotenuse. So this is the same thing as h over s. Now look at the triangle on the right triangle on the right. Again, I'm looking at the theta over 2 for this triangle here, and I'm going to use sine in this case. So I'm going to say sine of theta over 2. Now from that perspective, sine is the opposite over the hypotenuse. In this case, s is hypotenuse again. So remember, the length here is b. So this side here then is b over 2. The other side is b over 2. I'm looking at the angle, triangle on the right. So I'm just going to say the sine of theta over 2 is the opposite side, which is b over 2 over the hypotenuse, which is s. So from this one right here, I'm going to multiply through by s. Multiply both sides by s here and s over here. So I'm going to find h. Now the reason I want to find h is because I want to use this formula right here to find the area of this isosceles triangle. So multiplying by s, the s cancels here, so on the other side I get s times cosine theta over 2. Now for this one here, to simplify this first, I'm going to multiply the numerator by 2, the denominator by 2, and these 2's are going to cancel, and then in turn I'm going to multiply everything by 2s, this side and the other side. So obviously the 2 and the 2 here are going to cancel, and the s and the s are going to cancel. So here I'm trying to find b. b then is going to equal 2, and then of course I'm going to multiply the other side also by 2s, so that'll be 2s, and I have the sine of theta over 2. I'm going to go back to this formula right here. A is equal to 1/2, and now I have a base. I have 2s sine theta over 2 to represent the base, and the h is represented by s cosine of theta over 2. And then I would plug into this formula right here, and I would come up with this one. In case this is too messy for you here, let me just clear this. Remember, what I'm trying to get is this right here. So let me clear this right now. And all I'm going to do here is just show you in more detail, or something that's a little bit more clear. So here I have the same thing that I just went over, except I have it, hopefully you can see it a little bit better here. So I found h to be S cosine of theta over 2. We found using this setup here, simplifying, we found B to be 2S sine theta over 2. So this is what I just went over. And now I'm going to plug into this formula. So A is equal for any triangle. It doesn't have to be a right or a isosceles or equilateral triangle. As long as you know the base and the height, it could be expressed in terms of something else. In this case, I've had it expressed in terms of the sine and cosine. So have A is equal to 1/2 base times the height. Okay, so 1/2. And what do we get for the base? 2S sine of theta over 2. And what do we get for the height? Over here, the height is S cosine theta over 2. So all I did here is said, okay, we got an S here and an S here. Multiply those out. S times S, that's how I get this S squared. I left the 1/2 the way it is there, and I just grouped the other parts. So in this parentheses I have 2 sine theta over 2 cosine theta over 2. So we look at that clearly. All I did is make a substitution for the base and the height, and the S and the S give me the S squared. I put those out in front, and then the rest of it stayed in this parentheses. 2 sine theta over 2 cosine theta over 2. And then I remind you that there is a identity, or double angle identity, I should say. It says that if you have the sine of 2 theta, and there was the sine of twice any angle, that's equal to twice the sine of theta. So sine of twice an angle is equal to 2 times the sine of just the angle. Now this works both ways. You can go from left to right, go from right to left. So this tells me then that if I have twice the sine of an angle, that's the same thing as the sine of twice that angle. So in this particular case, theta over 2 and theta over 2 is the angle. So I rewrote it this way then. So this tells me then that for this part right here, notice the 1/2 S squared is the same over here. Just put it. It tells me you have twice the sine of an angle times the cosine of that same angle. In this case, the angle is theta over 2. Then that's going to be, okay, going here, that's going to be the same thing as the sine of twice that angle. In this case, 2 times theta over 2. So there's theta over 2 times the 2. So what happens here, of course, these 2 cancel out. And I get 1/2 S squared sine theta. And that's the way you derive it without using the other formula that I mentioned. I've done several videos on area of triangles, equilateral, general triangles. There's also Heron's formula that you can use when you know all 3 sides of the triangle. You don't have to know any angles. As long as you know all 3 sides, you can use Heron's formula to find the area. But anyways, here we just use some basic properties of right triangles, double angle identity to come up with the formula for the area of an isosceles triangle. Thanks for watching. We'll see you next time.